Dear students, now we are going to see the problems on Norton's theorem. So the problem statement is determine the Norton's equivalent circuit across the terminal AB for the circuit shown in the figure. So this is the circuit they have given. Okay. So the main difference between Norton's theorem and Thevenin's theorem is when we are going to calculate the Norton's current. Okay. So we have to consider a short circuit path between AB. While we are solving the problems on Thevenin's, we will use open circuit at these AB terminals, but in this case we are going to short circuit the AB terminals. That is the only difference. So if you see this first loop, this is the first loop. So in this first loop, generally what is the Ohm's law formula? V is equal to IR. Therefore I is equal to V by R. By using this formula, we are going to calculate the I1 current. So in the first loop, what is the voltage that we are having? In the first loop, the voltage is 40 and the current is 20. So the answer is equal to 2 amps. In similar way, we are going to calculate the current in the second loop. So the voltage in the second loop is 20 volts. So I have writing 20 here, and the resistance in the second loop is nothing but 10 ohms. So 20 by 10 is nothing but 2 amps. So if you see here, the two currents are in same direction. So that's why Norton current IN is equal to I1 plus I2. That is equal to 2 amps plus 2 amps. So that is equal to 4 amps. So finally IN is equal to 4 amps we got. So then what is the value that we need to find? We need to find the R Thevenin. So the R Thevenin is similar to that of the Thevenin's voltage, Thevenin's resistance method. So next we need to find the R Thevenin. R Thevenin calculation method is similar to that of the Thevenin's theorem. So here what we are going to do is we are going to replace the voltage sources with their equivalent resistance. So these voltage source is going to be replaced with short circuit. These voltage source is going to be replaced with short circuit. The AB terminals will be open. Now we need to calculate the equivalent resistance between these AB terminals. So now the equivalent circuit will be this 20 ohms resistor and these 10 ohm resistors are in parallel, and this will be the AB terminal. This will be the AB terminal. So from this place, if you are seeing, means this is the R Thevenin. Okay, this is the R Thevenin. So I am going to calculate the equivalent resistance for these two resistors which are in parallel. Okay, so generally what is the formula? 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So what is the R1 value? That is 20. I have substituted here. And R2 value is 10. I have substituted here. So finally we are getting the R Thevenin as 6.67 ohms. So the Norton's equivalent circuit is the current source in parallel with the resistance. So the current source is nothing but the I Norton. The resistance is nothing but the R Thevenin. So this is the Norton equivalent circuit. Okay, that's it. Thank you.